New unit, complex numbers. You've done this before in Algebra 2, I'm pretty sure. Do you remember what the square root of -1 is? Like up till now, all right, gentlemen. Up till now we've said, oh, we can't take the square root of negatives, we just can't do that. But all this time you knew that you kind of can take the square root of -1 if you know what you're doing. What's the square root of -1?
I.
Not 1, I. And then if you square both sides, I squared is -1. Those are the two sort of most important things you need to know for today. After that, I mean, there's some old stuff you got to know, but that's the two big things. So if the square root of -1 shows up, you can factor out an I, or take out an I. If I squared shows up, that's -1. So let's do just a quick little review on radicals. Simplifying radicals. Square root of 50. You remember how to handle that? Good. I like the way you said that. There's different ways to do it, but the easiest or best, in my opinion, way is split it up into a perfect square factor and the not perfect square factor. Because then you could take the square root of 25 and get 5, and so 5 root 2. And this is another one of those places where you don't really even need to show that. If your brain can see 25 and 2, square root of 25 is 5, then we're good. But what about the square root of -50? How do we handle that? I would add an extra step in here. I would take the negative out as an I. So you got I square root 50. And then it's the same one we just did. 5 square root of 2, but there's an I in there. 5i square root of 2. So that's one of the new, I hesitate to use the word new, you've seen it before, new to us this year. Square root of -1 is I. Square root -32 and square root -72. Why don't you try those two? Then we'll compare and then we'll keep rolling. So hopefully you got that for number 3. Number 4, if we split up this way, we're not quite done because I can split 8 up into 4 and 2. Now, admittedly, this is the long way around, but sometimes this happens because you recognize the square root before recognizing the biggest square root. So 3 times 2 times square root of 2 times I, 6i square root of 2. But yes, that means it would have been better to start with 36 and 2, because then you'd get the right answer a lot quicker. So you'd like to find the biggest perfect square that goes into your starting number, but if you start with something lower, like 9, that's okay. You just better keep checking what's still under the radical, because maybe it can simplify further. So either path is okay, but obviously you'd much rather take this path because it's just quicker. So look for the biggest perfect square that's a factor before you keep going. All right, powers of I. I guess if we're going Roman numerals, that'd be Roman numeral 2. Powers of I. So I to the first is I squared is -1. We said that already, both of those things. What do you think I cubed is? How'd you get -I? I agree with that.
Oh no, she didn't really tell us last year.
Okay, just remember it. Okay, it is negative I. If you get stuck, here's how I remember it. I cubed, the only way to get to I cubed is I squared times I. Well, I squared is negative 1, and I is just I. So we get negative I. How about I to the 4th? You could do I squared times I squared and get a positive 1. And then the pattern repeats after that. So I to the 5th is I. I to the 6th is negative 1. I'm not even thinking about these. I'm just following the pattern. I to the 7th is negative I. I to the 8th is 1. And so on. So basically, if it's divisible by 4, if the power is divisible by 4, the answer is 1. After that, you kind of just count up or back. That's, to me, the easiest way. So if I want to find I to the 35th, it's like, I mean, one way to do it is to count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You get there. I'd rather just say, well, I know what I to the 32nd is. And then that would mean I need 3 more i's. I to the 32nd is 1. I cubed is negative I. So I get negative I. So you can do some crazy high powers of I if you know your multiples of 4. Let's do I to the, I don't know, 42nd and I to the 17th. Why don't you try those two? I to the 42nd and I to the 17th. Count them if you must, but it'd be easier if you did the multiple of 4 thing. So I to the 42nd. 40 would be the biggest multiple of 4 before we get to 42. So that's 1. I squared is negative 1. So my answer is negative 1. I to the 17th, the biggest power that's a multiple of 4 is 16. So 1 times I is just I. So if you know your multiples of 4, it's not bad. If you don't know your multiples of 4, then you just got to count to 17, which it's not that bad to count up and still land at I. All right, all of those were imaginary numbers. Let's talk about complex numbers. Complex number. That looks like A plus BI. So BI, that's the imaginary part. And A is the real part, or the real number. So they're complex because they have both the real part and an imaginary part. Let's do some, we're just going to do some examples with it. We can just jump right in. I guess we'll say the instructions would be something like simplify, write answers in A plus BI form. Simplify, write your answers in A plus BI form. Most of the time there's no other form you could write it in, so that kind of happens automatically, usually. So let's say we got 5 plus I plus negative 3 plus 7i. Well, it's sort of like adding x's or adding y's or adding any other variable. Be careful, I is not a variable, I is the square root of -1, but it works the same when it comes to adding things. So I can add the real parts. 5 minus 3 is -2. Whoops, not -2, +2. And then I plus 7i would be 8i. Pretty simple. But hey, that's only example 1. -2 plus square root of -8 minus 5 minus square root -18. Alright, we just took a bit of a jump in difficulty level there. What do you think we should do first with those problems? Yeah, simplify that radical stuff, and then we'll go from there. So, square root of -8. An I comes out, then it's 4 times 2. So all of that is 2i square root of 2. Then we'll do the same type thing for 18. Negative comes out as an I. 18 is 9 and 2. So that would be 3i square root of 2. Okay, now we're ready to look for like terms. Minus sign. So I'm going to show the step that's next. You might get away without showing this step. But what's the most important? What am I about to do here? Distribute the negative sign. So if you don't show it, fine, but you sure better distribute the negative, which would make this a plus 3i square root of 2. Again, if you can get by without showing that step, that's fine. Just be careful. So let's see, we got -2 minus 5 is -7. And then how do we combine 2i root 2 plus 3i root 2? What does that become? 5i root 2. Right? The common thing is the I root 2. So I got 2 of them plus 3 of them. And that gives me 5 of them. 5i root 2. That combines some simplifying and some distribution and like terms. A lot of little things going on in that one. We better do the fraction one just to make sure we're okay. -1/2 plus 3/2 I plus 5/2 plus 13/2 I. Why don't you try that one? I bet you can handle that one. Careful with that leading negative sign though. Fractions, but not too bad. Alright, let's switch to some more stuff with i's that think things a little bit harder. 3i times 7 plus 2i. Well, let's distribute the 3i. So 21i. 3i times 2i would be 6i squared. That answer's not wrong, but it's not finished. Because I squared is -1. I'm going to show all the steps on this first one here. I squared is -1. So this becomes 21i minus 6. And this is another place where it's like that answer is not wrong, but we usually like the real part listed first. So negative 6 plus 21i. In fact, I'll just box them both because they're both acceptable. The second one's preferred, but not preferred enough that I'd take off any points for it. Preferred in that on a multiple choice, it would be written like that. But I don't think there's any problem going from this form to this form. So the big thing is, when you see I squared, replace it with negative 1. Or what many of you will do is, when you see I squared, just change the sign of whatever number it's attached to. Two minus 3i times 4 minus 5i. Well, what are you going to have to do on that one? Yeah, distribute or FOIL. So you try that one, and so 8 minus 10i minus 12i minus 15. Again, I would just fix it right there. As soon as I squared shows up, change the sign. 8 minus 15 is negative 7. Negative 10 minus 12 is negative 22i. So, mostly skills that you already have, probably pretty good at. Just don't forget that I squared is negative 1. All right, this next one can present difficulties to people because they try shortcuts that they're not allowed to try. Square root of negative 5 times square root of negative 5. I don't even know if I want to show you the wrong way.
Is there a square root of 5?
There's not a square root of 5. You're right, we're kind of stuck with that. But what we can definitely do is take the negative sign out front as an I. So I root 5 times I root 5. So we can multiply the i's and get I squared. What do we get when we multiply square root of 5 times square root of 5? 5. Good. I don't even want to hear root 25. The roots cancel each other and you're just back to 5. And I squared is negative 1, so the answer is negative 5. Again, I don't think I even want to show you the misleading way for fear that you'll do it that way. Three more. You know what? Let's do 2 more. 3 plus 4i times 3 minus 4i. So another FOIL problem. What's unique about this FOIL problem? Do you remember the name for what's going on here? When we change the middle sign, it has a special name. The conjugate, we multiply by the conjugate. So watch what happens. So FOIL that out. Something kind of funny, weird, unique, helpful happens. So FOIL that out, and we'll pick some more volunteers. I'm going to press pause. So if you're watching at home, FOIL it out, and then we'll check back. So the answer is number 7. First outside, inside, last. O and the I cancel. I squared changes that sign. 9 plus 16 is 25. Conjugate, the i's always cancel out. Number 8. Did y'all do I stuff in Algebra 2? Okay. So do you remember how to fix this one?
Oh, you put the I is at the bottom, right?
The I can't be in the bottom because I is a square root, and we don't like square roots in the denominator. So that's why it's broken. That's why we don't like it, because that I is down there. But you multiply by the conjugate, and that'll get the I out of the denominator. So I'll multiply the top and the bottom by the conjugate. And that should fix the bottom. The top, who knows what mess we'll have up there, but it should fix the bottom. Yes, sir?
The conjugate's always the one with the denominator. It always equals multiply.
Yes, the conjugate of always of the denominator, because the denominator is the one that's messed up, because that's a square root in the bottom, and we don't like that. So we change that middle sign, and now we have two FOIL problems to do. Probably none of you still write FOIL on your paper, but if you need to, by all means. First, outside, inside. It's last, 3i times 4i. Wait, last on the top, 3i times 4i, which is negative 12. I start to fix that on the fly if you want to. So the top becomes negative 10 plus 11i. And then in the bottom, the i's are supposed to go away. Let's see what happens. First, outside is plus 4i. Inside is minus 4i, sure enough. And last is minus 16i squared. So plus 16. And 1 plus 16 is 17. And here's another spot where that's a perfectly acceptable answer, but the instructions did say to write it as a plus bi, so we might split up that 17 and write it like that. But again, I would not mark off if you had the previous thing on there. All right, today's assignment's worksheet 1.